Hey guys, it's Miss Johnson, and today I'm here to bring you our video for Unit 5, Notes 5. Today we're going to talk about applying quadratic equations. So we need to think about what words in an application question are going to tell us that we need to find the vertex of a parabola, and what words tell us that we're going to need to solve the parabola. So let's just review. Vertex of a parabola, we learned this back in Unit 5, Notes 1, so if you need to remind yourself, you can look back there. But the vertex of a parabola is we find that using x equals the opposite of b divided by 2 times a. And then that's only half of our vertex. After we find that, then we'd plug it in to find y. So that's how we find the vertex of a parabola. And then just let's talk about what in a question might tell us that we need to find the vertex. So when we see words like maximum and minimum, that tells us that we are looking for the vertex. Minimum. There we go. Maximum and minimum, because that's what the vertex is. The vertex is the maximum of the parabola if it's opening down, or the minimum of the parabola if it's opening up. So when you see phrases like find the greatest height, that suggests to you that you're finding the maximum. Or if you're looking for something like least cost, that suggests to you that you're finding the minimum. Those are just two examples. Of course, there's lots more phrases that can tell you it's max or min, but you're looking for those extreme words, those words that tell you you're on the very top or the very bottom of that parabola. Okay. Then there are some times that we have to actually solve the quadratic when we have to solve for x. Okay, so when we solve in three different ways. We solve by graphing, we solve by factoring and doing the zero product property, and then ZPP. Or the one that I think that we use the most, we solve using the quadratic formula. So then the things that tell us that we need to solve are when we see phrases like when will it hit the ground, or hit a certain point. Okay, because this is, when we solve a quadratic, we're solving for x or t. We're looking, x and t are usually representing time. So unless it says something like find the values of x, or it might say when, or find the number of seconds, that's that independent variable. The independent variable is the x or the t. So we're looking for when it hits the ground, or when it hits a certain point, hits a certain height. Okay. So that phrase when, or something that refers to how many seconds, is going to be a big indicator of us needing to solve. So let's just practice determining these two and actually using some of these things. In number one, it says the height h of an object t seconds after it is propelled upward with an initial velocity of v is represented by that equation, where g is the gravitational pull and h is the initial height. So suppose an astronaut is up on the moon and they throw a baseball from 2 meters above the ground with an initial velocity of 10 meters per second. Suppose the gravitational pull on the moon is a constant of 1.6. How many seconds, there it is, will it take for the baseball to return to the ground? So how many seconds, that phrase tells me that I need to solve. Okay, so I'm going to solve either graphing, factoring, or quadratic formula. I look at this equation, there's a lot going on in it. I already have a fraction in there. I'm going to put some decimals in there, so I'm deciding to use the quadratic formula. Let's first take a look at what this equation is. The other thing that we need to recognize is that when things hit the ground, our height is 0. So we're looking for when this height is equal to 0. We have that negative 1/2. I need to fill in the gravitational pull, which is g. This g is going to be 1.6. Then I have the t squared. Then I need to fill in the velocity of 10, so 10t. And I need to fill in the initial height. So the initial height from 2 meters above the ground, that's my initial height. Okay, so there's my equation. Right away, I recognize that I have these two things that are being multiplied together. So I'm going to go ahead and take care of those because that makes my life a little bit easier. Well, negative 1/2 times 1.6 is negative 0.8. So I have negative 0.8 t squared plus 10t plus 2. That's the equation that I'm working with, and that's the thing that I want to solve. I want to figure out what t is because that's what seconds are. Seconds is the t. So I'm going to use the quadratic formula. I think this looks like it might be ugly to graph, and it has some decimals, so I don't really want to factor it. So I'm going to use the quadratic formula. Here's what the quadratic formula looks like when you set it up. T is going to equal the opposite of b, so negative 10, plus or minus the square root of 10 squared minus 4 times a times c, which is 2. And then that's all divided by 2 times a, which is negative 0.8. Now, I'm not going to take you through this entire quadratic formula because I think you don't need to watch me do that. If you need help with the quadratic formula, come see me in class and we can talk about it together. But after I got through this whole quadratic formula, I got down to the two answers. T was equal to I got down to the two answers of negative 0.2 seconds and also 12.7 seconds. So then when I look at those two answers, obviously it's not possible for us to have a negative time, so that one's going to be out, and this is my best choice. So it took 12.7 seconds for that baseball to reach the ground when it was thrown on the moon. Now obviously that sounds like a long time for a baseball to take to hit the ground, but we're up on the moon, so gravity is a little different. Now let's look at part B. Someone threw the ball from the same initial height, that's the 2, same velocity, that's the 10, where the gravitational pull is now 9.8. So we're back on Earth. Now my gravity is 9.8 instead of the 1.6. When will the baseball hit the ground? So I'm still looking for h equals 0. The only thing that's changed is this 9.8. So my equation looks like this. 0 equals negative 1/2 times 9.8 t squared plus 10t plus 2. So again, notice that it looks the same as this equation, except for that 9.8 has changed. Again, I'm going to multiply those two in the front together, the two a's that are there. You can put them together. So that's negative 4.9 t squared plus 10t plus 2. So when I solve this one, this is the quadratic formula that I get. I have the opposite of 10 plus or minus square root 10 squared minus 4 times a times c all over 2 times a. So quadratic formula looks very similar. The only thing that's changed is that a value, because now my a value works with a different gravitational pull. Again, I'm not going to take you through the quadratic formula, but just know that you have to go through those steps to get to the bottom when you do this on your own. And I ended up with the following two answers. I had t was equal to negative 0.18 seconds and 2.22 seconds. Now, again, we're talking about time. It doesn't make sense to have a negative time, so that one's got to be out. This has to be my answer, so 2.22 seconds there. And then in part C, it says compare the two. What do you notice between the time it takes the baseball to land on the moon and the time it takes the baseball to land on the Earth? On Earth. So on Earth, it's much faster. That's what I notice. And my reasoning behind that is the fact that gravity is much stronger, so it pulls it back down a lot faster. Okay, that's my findings. Okay, let's take a look at number 2. In number 2, it says Jimmy John's is tracking its sales of subs. The manager sees that the quadratic representing this equation is this one right here, where X is the number of subs sold and Y is the revenue earned. Revenue is money that comes into the company, just for in case you haven't heard that word before. What is the maximum revenue earned and how many subs were sold to earn this revenue. Okay, maximum, there's our key word. This tells me that I need to find the vertex of the parabola. So I am looking for the vertex of this equation. That means I need x is equal to opposite of b, that's negative 250, divided by 2 times negative 25. That's my a value, so negative 250 over negative 50, and I end up with 5. Then that's my x value, so that's x is the number of subs sold, but my y value is when I plug that x back in. So negative 25 times 5 squared plus 250 times 5 plus 400. That's negative 25 times 25, which is going to be negative 625, because 5 squared is 25, so then I multiply that by the a, plus 250 times 5, which is 1250, plus the 400. I end up with 1,025. So 5 subs is my x value, and $1,025 is my y value. I'm told that x is the number of subs, y is the revenue earned. So that is my revenue. In number 3, it says a projectile is shot up vertically up in the air from ground level. Its distance y in feet after t seconds is given by that equation. Find values of t when y is 96 feet. So we are given a y value here, so I can plug a y value in for that, and it says find values of t. So this finding values of t tells me that I need to solve. So I'm going to solve this equation. But first, before I solve that equation, I need to plug that y value in. So I have 96 is equal to 96t minus 16t squared. That's the equation that I'm working with. Now, I can't solve this until this is set equal to 0, so I'm going to subtract the 96 from both sides. 96 is a constant. This is a t, and that's a t squared. So I can't combine it with either of these two things because none of them are like terms. The other problem that I have when I look at this equation is the fact that my a value is actually in the middle. So be very careful about those variables that you're looking at. That's your t squared, so this is your a value. So I'm going to rewrite this whole equation with my a value now in front. So negative 16t squared, this is my b value because it has the t, so plus 96t, and then my constant is the thing that I'm subtracting, minus 96. That's the equation that I'm working with. And again, I'm solving for t. I tried, first of all, because I recognized that these were all going to have a GCF that I could take out, I tried to see if I could factor this. I noticed that 96 and 96, obviously, same number, are both divisible by 16. So I divided the whole thing by negative 16 in hopes that I would get a 1 in front of that t squared, and then it would be really easy to factor. Well, 0 divided by negative 16 was 0. Negative 16 divided by negative 16 is that 1 that I was looking for. Then 96 divided by negative 16 was negative 6. And then 96 divided by negative 16 is going to be positive 6. Negative divided by negative gives me positive. So this is the equation that I then got after I did that. It still wasn't factorable, so that was kind of disappointing. I can't get a product of 6 and a sum of 6 at the same time. So not factorable means I had to use the quadratic formula. Now, the nice thing about what I did though is that my quadratic formula is going to be a lot easier with this equation than with that one. My numbers are a lot smaller, so they're a lot easier to work with. So that's what I did. T is equal to the opposite of b, which is now positive 6, plus or minus square root of negative 6 squared minus 4 times a times c all over 2 times a. I'll take you guys through this quadratic formula so you can see me do one of them. The negative 6 squared is positive 36. Be sure when you plug that into your calculator that you put parentheses around it. We all know that a negative times a negative is a positive. Then minus 4 times 1 times 6, which is 24, all over 2 times 1, which is 2. I end up with 6 plus or minus the square root of 12 all over 2. And now I take the square root of 12. So 6 plus or minus, and the square root of 12 gave me 3.46. I guess I should technically be putting approximately equal to now. And then I would split that off from there. So this was t is approximately 6 plus 3.46 all over 2, and t is approximately 6 minus 3.46 all over 2. Um, I need to make sure that I do that first. So 6 plus 3.46 gives me 9.46, which then gives me a t value, once I divide it by 2, of 4.73. Then 6 minus 3.46 gives me a t value of, or I'm sorry, gives me a value of 2.54 over 2, which is a t value of 1.27. So, two positive answers here. I have a positive answer of 4.73 and a positive answer of 1.27. These are both true. What's happening here is, let's say this is the projectile. It's going up and then it's coming down. Well, we want to know when it hits 96 feet. That's the 96 feet that I have going on there. So it hits it in two spots. It hits it going up, which we can assume is the 1.27 seconds, and it hits it coming back down, which is the 4.73. So in two places, both are viable answers, are true answers. So 1.27 and 4.73 seconds. All right, so let's move on here to number 4. So in number 4, it says a pan is to be formed by cutting 2 centimeter by 2 centimeter squares from each corner of a square sheet of metal. Um, or a square of sheet metal, I should say, and then folding the sides up. So they take the sheet metal, they cut the corners out, and then they fold the sides up to make a pan that you can put in the oven. If the volume of the pan is to be 441 square centimeters, what should the, and that should say cubic centimeters actually, because it's a volume, it's 3 dimensions. What should the dimensions of the original piece of sheet metal be? Original piece of sheet metal. Okay, this is quite a complex problem. So you know that you're looking at this original square that then gets these corners cut out and folded up to make the pan. What you know about the pan is its volume. So if you think about volume, volume is equal to length times width times height. So I need to figure out and I know the volume of the pan once it's created, once those corners are cut out and the pieces are folded in. So I need to think about what are the dimensions of the pan once it's created. Well, the length of the pan is going to be this bottom piece right here, which is x minus 4. The width of the pan is going to be the same thing because it's a square, x minus 4. And by the way, that x minus 4 comes from having a length that is x and taking 2 centimeters off of each side because those are the pieces you're going to fold up. So take 2 off of each side, that's taking 4 off of the whole length. Then the height comes from what did we take off the side? We took off the side a 2. So those are the 3 dimensions of the pan. The other thing that I know is that the volume is 441. So I have 441 equals x minus 4 times x minus 4 times 2. All right, so now I need to simplify this equation because I can't really do anything with it the way it is right now. I see that I have a binomial times a binomial, so I need to multiply those, which if you think way back to Unit 3, that was when we FOILed or set up a box. So if I FOIL, it's first times first, which is x squared, first times last, or outside times outside, negative 4x, inside times inside, negative 4x, and negative 4 times 4, those are the last times last, which is positive 16. These are my like terms, x squared minus 8x plus 16. So that, by the way, in case you've forgotten, is the FOIL method. Some of you also set it up in a box, which works as well. X, -4, X, -4, find them, add them up, and you get this. Okay, so I know that 441 is equal to x squared minus 8x plus 16 times 2. I also need to take that 2 and distribute it throughout the whole equation. So, or that whole expression, I should say. So 441 is still my volume. Now I have 2x squared minus 16x plus 32. Okay, I'm getting closer, but I cannot solve this until I set this equal to 0. So I have 0 is equal to 2x squared minus 16x, and then I do 32 minus 441, which gives me negative 409. So that is the equation that I'm solving. And by the way, I don't think I addressed this at the beginning. I know that I'm solving because it's looking for the dimensions of the original sheet of metal, which is this x by that x. It's a square because we're told that it's a square. So since I'm looking for the x values, I know that I'm solving. There's nothing about max or min in this question. It doesn't say anything about the greatest or the least or maximum or minimum. So I'm not finding the vertex. I'm solving. Okay, so this is the equation that I'm using to solve. Now I gotta actually solve it. I did all that work just to get my equation because I didn't have an equation written. So now I have to actually solve it. I'm gonna plug it into the quadratic formula. So it looks like this. X is equal to positive 16 plus or minus the square root of negative 16 squared minus 4 times 2 times negative 409. That's the 4ac part, all divided by 2 times a, which is 2. 16 plus or minus. negative 16 squared is positive 256. And then negative 4 times 2 times negative 409 was positive 3,272. And you can be plugging these all into your calculator as I go through them to make sure that you get the same answers that I do. So when you do this on your own, you know that you're doing it right. Add those together, I get 3,528 divided by 4. I need to take the radical next, so the square root of 3,528 is approximately 59.4 over 4. Then it splits. I split it into x equals, this is why you have a lot of space on this page, by the way, or for this question. Oops, not 16. 59.4. So plus 59.4 divided by 4, and x equals 16 minus 59.4 divided by 4. Well, for this one, I get approximately, and I suppose I should have had approximately up there, I get approximately equal to 18.85. Over here, I get x is approximately equal to negative 10.85. So now think about what you're being asked to find. You're asked to find in the original question the dimensions of the sheet metal. So if I'm looking for dimensions of a sheet metal, it's not possible for me to have negative 10.85 centimeters. I got to get rid of that one. So my best choice here is 18.85 centimeters. And since it's a square, the other dimension is the same thing, 18.85 centimeters. There you go. Last question, number 5. It says on one of the banks of the Chicago River, there is a water cannon called the water arc that sprays recirculated water across the river. The path of the water arc is given by the quadratic model like that. So the water makes this parabola that is then going across the river. X is the distance across the river, and y is the height of the arc. What is the maximum height of the water, and how far across the river does the water reach that height? Okay, maximum, there it is. Maximum tells me I'm finding vertex. So I want the vertex of that equation. That means I need x is equal to the opposite of b, negative 1.2, divided by 2 times a, which is negative 0.006. That's negative 1.2 divided by negative 0.012. Divide those two, and I get positive 100. Negative divided by negative gives me positive. Then I need to find, so that's my x value, then I need to find the y value. So negative 0.006 times 100 squared plus 1.2 times 100 plus 10. 100 squared is 10,000, and 10,000 times negative 0.006 is negative 60. Plus 1.2 times 100, which is 120, plus 10, which when I put all those together gives me 70. So my x value is 100. My vertex looks like this. Your vertex is 100 comma 70. So what that means is the max height is the y value. Y is the height. Max height is 70, and we're looking at feet, I think. In feet, yep, so 70 feet. And that happens at 100 feet across the river. So that would be this point approximately right there. All right, so that takes us to the end of Unit 5, Notes 5. So this was a lot of applications in here, a lot of things that we were looking at. So please take the time to make sure that you understand the questions that you're being asked. If you have questions still, come and talk to me and I will help you through them. Thanks for listening. See y'all later.